Hi, it's Kate, and I'm recording this session of the Urban League Task Program on July 16th, which is Shark Awareness Day. They want us to be aware of the fact that sharks are pretty interesting creatures that deserve a spot on this world with the rest of us, despite some of the bad press they get. There are over 400 types of sharks. They go from very small and friendly ones to actually rays, like the manta rays. You wouldn't expect them to be part of the shark family. They also have a very keen sense of smell, and they're attracted to bright colors like orange and yellow, and contrasting patterns like black and white, very dynamic. A bathing suit like that might make you look like something they definitely would like to eat. So there's a lot to respect about sharks, but there are some things to be aware of. And we're going to be focusing on two things today. In math, it's going to be the properties of circles, and in science, it's going to be on the solar system and some of the other heavenly bodies that are out there that keep us company and that huge, vast expanse of space. Kind of hard to wrap your mind around how big the universe really is. I kind of got myself in the mood by using this background, and hopefully some of it will rub off on you, because at this time of year, there's some really good sky gazing. If you can get to a spot that's dark enough, you can see what's going on up there. Let's start with the math first, and I'm going to try to get my share screen to pick up on the lesson I want you to learn, but that I want to share from the Khan Academy website. They provide a lot of support for instruction on there. So let's see if I can get that up and share it with you. Okay, coming back your way. Okay, looks like we have a success. Now, the way the Khan Academy is set up, and you should be able to get to all different parts of it when you log on after you've created your own account. You come in through My Task class, and you will get credit for any work that you do and time that you spend on your own outside of class doing review. So it's really handy whenever you might have the urge to do a little math. And they also teach to mastery, which means that they'll continue to ask you more difficult questions so that you can retest in the same area until you've really got a solid understanding before you move on. So today we're going to start with the very basics: radius, diameter, circumference, all properties of a circle. Now I know some of you are saying, hey, wait a minute, this is geometry, and we're not there yet. Well, yes, you're right, it is, but it certainly can be taught as a separate standalone lesson, and it is also touches on two formulas that they will not provide you on your math reference sheet. So you really need to memorize and feel very comfortable with using the circle formulas for circumference and area, because you need to know those going in. They will not be provided. But let's start with the basics. What is a circle? Well, a circle is simply a number of fixed points that are all equidistant, meaning the same distance from a center point. So every circle has a center and set points around that center. And the distance between the center and one edge is the radius. That's represented in any of the circle formulas by a small letter r. The radius is only half the distance across the circle. So think of it as kind of the hands of a clock. So in which one of the segments in the circle below is a radius? And this is what else is cool about the Khan Academy, is that they provide you with some practice, and they provide you with questions and give you immediate feedback on your answer. So which one of the segments in this picture could be considered a radius? It looks to me like we've got A going from the center to the edge, and we have B going from the center to the edge. Oh, it's not letting me choose. I wonder why. Well, And then this is only going from edge to edge, but it doesn't touch the center. This is called a chord, C-H-O-R-D. Not a chord that you can sing or play, but this is a chord because it does not go through the center, but it does touch each edge of the circle. I'm very disappointed here that I can't choose, but I will tell you, oops, wait a minute, now it's woke up. Nope, I guess not. Okay, I will tell you that A and B are the radius. Now, if this was working, we would push check, and it would tell us if we were right or wrong. If our answer was wrong, then we'd be given an option to click on explain, and it would explain why it's not correct and how to get the right answer. Now, moving right along, the diameter, as you can see, is made up of 2 radii. So the diameter actually goes from edge to edge and through the center. So you can think of a diameter as being twice as long as the radius, or a radius being half the length of the diameter. So now, just to see if we've been paying attention, which of the segments in the circle below is a diameter? Well, in this case, my friends, there's only one, and that is Mr. Green B. It isn't A because, as we know now, that's a radius. And it isn't C because, as we know now, that's a chord. So the only one that meets the description of a diameter is B, because it goes from edge to edge and it touches the center. Darn, I wish this would let me click, because it's so much fun to hear the boop when you get the right answer. I know, I'm amused by little things, but hey, it's nice sometimes if you don't have a lot of money, the things that are free. Okay, now the diameter is really, as I just pointed out, 2 radii. And that, for you that never took Latin, is the plural of radius. US, the plural is I. So here you can see, if you had any questions, that 2 radii make the diameter. And we can represent this, now don't get freaky on me, we can represent this by an algebra expression or a formula that D, diameter, equals 2R, and that's radius. So instead of using words in a sentence, we can simply say D equals 2R. So given a radius, we can come up with the diameter. For example, here we have a radius of 6. That means that we have a diameter of 12 because D equals 2R. If R is 6, then D is 12. In the opposite, we can find out the radius if we are given the diameter. All we do is cut the diameter in half. So if the diameter is 10, we know that we have a radius of 5. Now, why would we want to do that, you say? Well, good question. It depends on how the question is asked of us. They might give us the radius and ask us to determine something with the diameter. They might give us a diameter, and if they asked us to determine the area, we'd have to change the diameter and figure out the radius to work that formula. So it's useful to know the relationship and how they relate to each other. Now, the circumference of the circle is the distance around. If this was a square backyard, you'd call it the perimeter. Like, how many feet of fence would you use to fence in your yard? But for a circle, it is called the circumference. And the area is everything inside. So here we have 2 circles. We're given the circumference and we're given the diameter. Now, there is an interesting relationship here. And maybe you've already heard the expression pi. Now in math, pi is spelled P-I, and it's represented by a specific symbol. which is right here. It looks like a little, I don't know, some kind of a hut maybe. But pi means 3.14. It represents that number, 3.14. It also represents the relationship between the circumference of any circle and its diameter. So if you want to, you could determine the diameter if they gave you the circumference of a circle. Yes, that is true. And this is how you would do it. You would simply divide the circumference by the diameter, and you will get pi. So that means if you divide the if you divide the circumference by pi, you'll get the diameter. Let me prove that to you. Okay, here they're giving us our first formula. C always means circumference, if it's a capital C, equals pi times diameter. So if the circumference of a circle is, as they said up here, 6.28318, and you divide it by the diameter, you will definitely get pi. If you divide that circumference by pi, you will get the diameter. And let me prove it to you. Okay, here we have a circle with a diameter of 10. Using this formula, we're going to plug D equals 10 into the formula. So it becomes, instead of C equals pi D, it becomes C equals pi times 10, which is D. So the answer is circumference, or C, equals 10 pi. You might be able to leave it just like that. Sometimes the question will say, what is the circumference in terms of pi? That means you don't have to substitute the numerical value. You can just use the symbol. But if they ask you for the numerical value, then you would substitute 3.14, and that means that you would multiply 3.14 times 10, and you would end up with 31.4 as your circumference. But let's do the first one here that allows us just to keep it in terms of pi. All right, we have got, not a diameter. They gave us a radius, but that's not going to be a problem because we now know that the radius is twice the radius is the diameter. So if we've got a radius of 6, that means we've got a diameter of 12. Come on, give me my, darn, I got to go back. I was trying to grab the little, where did that go? Yeah, I was trying to grab the little pen up there. There you go. All right. So here's our radius, and 2 times radius is the diameter. So that would be 12. Now, we know that circumference equals pi d. So if our d diameter is 12, then our circumference is 12 pi or pi 12. In multiplication, it doesn't matter which comes first. So the circumference is 12 pi. For some reason that just sounds better to me. Okay, let me get out of here because I can't move my page unless I get out of the share for a minute. Okay, now Khan Academy will give you challenge problems. And what that means is they're going to give you something that they didn't really tell you directly to see if you can put it together. So let's look at what we know here. This is, if you could imagine in your mind's eye, half of a circle or a semicircle. And this is the diameter. So just because they don't give you the full circle doesn't mean that you can't talk about it. So we now know that a circle would have the complete circumference. A semicircle would be half. So we still have enough information to work that problem. And anything that is not a complete circle, 360 degrees, is called an arc. So this is a semicircle. It has an arc of exactly half 360, 180 degrees. So the arc of this semicircle, okay, is 360 degrees divided by half, which would be 180. It also is in length half of the circumference. So that means, if we remember our formula, our circumference is pi d. This would be, we got a radius of 5. That means a diameter of 10. So it is 10 pi, our circumference. Divide that in half, and it's 5 pi. Now, some of you are probably saying you did one too many steps there. You could have made it simpler, and you're right. I just wanted to see if you're paying attention. Because if this is half a circle, and we know that a radius is half the diameter, we could have just multiplied radius times pi and gotten the same answer. Because we're only talking about half the circle, so we only have to talk about half the diameter and get the same, but we would have gotten the same answer either way you worked. Okay, so there we go. So that ends our first introduction to circumference, and the next session we'll do area. And if you go on the Khan site yourself, which I hope you will do, there are more practice questions for you to see how well you understood what I was explaining to you, or how well I explained what I wanted you to learn. Either way, hopefully we both end up doing our job. Now, moving on to the area of the circle. Okay, it's not going to let me do that, folks. I don't know why. All right. Oh, I guess it's just delayed, maybe because of weather. Okay, now, the area of a circle is, oh, I know why I didn't pick this. Okay. All right, the area of a circle has a formula as well, and that's pi times the radius squared. That's pi r squared. This is why I really wanted you to understand the relationship between diameter and radius, because you cannot use the diameter easily in this formula. It's much easier to use the radius. So you need to be able to know how to get that information if it isn't given to you. So finding the area of a circle when they give you the radius is the formula A equals pi r squared. So we have a radius of 5 here. So the equation for the area is pi r squared, means that it is pi 5 squared. Squared, you remember, is any number times itself. So 5 times 5, or 5 squared, is 25. So the answer is A equals 25 pi. Now, if they asked you to do the numerical value, not to leave it in terms of pi, then you'd plug in the value of pi, 3.14, times 25. And your answer would be 78.5 square units. Now, unit could be inch, could be yard, could be feet, could be centimeters, could be miles. Just remember to give the answer back in the units it was given to you. It's, if you have to show your work on the, don't lose points for that. Be sure to label. Now, if they gave you the diameter, you would simply cut it in half. So here you've got, they want you to find the area of a circle with a diameter of 16. First thing you do is divide that in half because you only need the radius. So the radius is 8. Then you plug in to the area formula. All right, A equals pi r squared. We know that our radius now is 8, so A equals pi times 8 squared, and 8 times 8 is 64. So A equals 64 pi. And plugging in the value of pi, A equals 3.14 times 64, or 200.96 square units. All right, so what is the area of a circle that has a radius of 7? Well, pi r squared means that we would be using the formula A equals pi times half of 7, 3.5 squared. Oh, no, never mind. I'm sorry, forget what I just said. I forgot that we had the radius already. Never mind. So the formula is A equals pi r squared. Now A equals 7 squared. A equals pi times 49, because 7 times 7 is 49. Now we just have to multiply 3.14 times 49. And if I get my calculator, you won't be able to see me do it. Let me just see if we can get our explanation. Okay, they're showing us that we first had to use the radius of 7, square it just as we did. So A equals pi times 49. Multiply 49 times 3.14, and we get 153.86 square units. Okay, and then if we wanted to do some more, you could click right here, and we could do a couple more problems. But for today, I'm saying let's stop here. We've done circumference, which was 2 pi r, or pi d, and we've done area, which is pi r squared. We've done problems that let us keep the answer in terms of pi, and we've done ones that wanted us to plug in the numerical value. So I think we've done a lot for a short period of time. So I'm going to leave this with you now for you to check on your own, because I really want to make sure that I have time to show you some of the light show that's going on in our skies right now. So let me get back to you. Okay, I'll just stop sharing. That'll be the easiest thing to do. Okay, right now we have in our skies the potential for meteor showers. We also have a comet that has never been seen before, which is really exciting. So I want to get that up for you. I've got a PowerPoint presentation, which I should be able to grab really quick. And there we are. Hopefully everything will open as it should. Might take a second here. All right, there we go. I want to come back to share with you and get this to open up, so go away. Okay. That looks very promising. Okay. I label this "We're Not Alone" just because, we're always talking about, is there other life out there? Well, I don't know. I I don't know. I think there has to be, because the universe is just so large. But right now in our solar system, we are the only one that has the things necessary to sustain life as we know it. Now, out there with us are asteroids, rocky, airless leftovers from the formation of planets in our own solar system. They hang out in a belt called, wait for it, asteroid belt, that's between Mars and Jupiter. So that's where this picture was taken by one of our space satellites or explorers. They have no air. They are rocky. They orbit our sun, not the Earth, but they can come pretty close to us. And every now and then, yes, I don't want to scare you, but every now and then they do hit. They're thinking that it was a large meteorite or asteroid that may have accounted for the disappearance of the dinosaurs, because some tremendous impact hit our planet and actually shifted the poles a little bit off the regular axis, because they have found woolly mammoths frozen in the ice that still had green grass in their stomachs. So one minute they were eating grass in what had to be a pretty, a moderate climate. The next minute they were flash frozen, which suggests something happened in the blink of an eye. And these are really a range of sizes. They go from the size of cars to the size of a dwarf planet. Now, speaking of that, you probably learned about the solar system when we had 9 planets. Now we've got 3, Earth, Venus, and Mars, that are in the, Mercury, Venus, and Earth, that are in the inner solar system. And then we had 3 in the way back in the outer solar system that were Uranus, whichever way you say it doesn't sound good. We had Neptune and we had Pluto. But Pluto was dropped from the batting order because they decided that it really was more of a comet, because it had a lot of ice in its composition. To be a planet, you got to be solid. So, but here, speaking of comets, comes a brand new one. Isn't this gorgeous? This picture was just taken in the northern part of Great Britain. So it is visible in our northern skies. Now, comets are really dirty space snowballs. They've got mostly ice and dust and little particles that have accumulated. They were formed at the birth of our solar system, you guys, back 4.6 billion years ago. So most of the comets have very stable orbits, although they're not necessarily round orbits. They're more elliptical, longer in one part than the other. And they go around the sun, and they go all the way out to the end of our solar system, past the planet Neptune. So we don't always see them that often. Like Halley's Comet comes around every maybe 76 to 77 years, but they're fairly predictable. The only time you can really see that tail is when they get close enough to the sun to start to melt, and so that puts off all the vapor from that melting gas and ice. Okay, now the next is the meteors. Now they look like a comet, but they're not, because they only catch on fire when they come into our atmosphere. The friction of the air in the atmosphere causes them to glow red hot and eventually put out streaks of flame. So these are what we call our shooting stars. And starting in the middle of August, we should be able to see a real light show of them if you can get someplace dark enough. Ambient light from street lights and stores and parking lots and houses make it harder to see the contrast. But if you can get someplace dark, you should be able to see one about every minute if the sky is clear, starting about the middle of August. These are called the Perseus meteor shower. It is named after the constellation Perseus. That's how they name the showers, is where they appear in the sky. And the meteors can be as small as a grain of sand or the size of a boulder, maybe 3 feet wide. But they definitely get smaller when they enter our atmosphere, and very few ever hit the ground. But when meteors come into our planet atmosphere, the meteorites become meteors. And when they hit the ground, they're the meteorites. And sometimes they can be collected. And some have actually come from the moon because they've been able to match them up with the moon pebbles that our astronauts brought back. Okay. Now let me get out of here. And I just wanted you to know that that planet is, or that planet, I'm sorry guys, I must be getting tired. That comet that I showed you that they took a picture of in the United Kingdom, Great Britain, this is the first time it's been seen. It's called the Neowise comet. We don't know how long it'll be visible, and they're going to keep an eye on it to see when it might be back. But it's going to go out from here to the edges of our universe. And I guess some of them have been out there so far that they're just coming into our view now after 4.6 billion years. What an incredible stretch of time, guys. Try to wrap your head around that. Okay, now what I would like you to do to follow this up is there is a review lesson, 1 page with practice questions on the test site. They're the people who make up our review books. And hopefully you will be able to open up your account on that site. I'm going to take you through it very quickly right now before my time runs out. What we want to do is go to the test. Okay, let me come back to share. Okay, I want to go on the contest site right here and create a little account. But I have to convince them. Okay, so it's CAP test. Okay. And it's books. Okay, online. Okay. When you get here, you should see exactly this. And you're going to pick the test, which is task, down here and click on it. And it will take you to a choice of 2 books. You're going to click on register for the 4th edition. When you get there, they're going to ask you for a word because they want to know that you've bought the book. Well, technically you have, because we bought 12 or 14 of them to use in class. So I'm not cheating them. Okay, and the word that you're going to put in there is people. That's the word that answers that question. If you ever played Where in the World is Carmen Sandiego, you know the drill. So you put in people and continue. Now you will create your own account. And what this does, allows you to, okay, come on, log me in. Oh, it's not going to recognize me now. Pooh. Okay, it will allow you to access material that there wasn't room to put in the book. So once you create your account and you click on your resources, you can open up the earth science, the physical science, and the world history lessons and practice questions. So you need to get these lessons. And what I'd like you to do is to open your account and do the solar system lesson, which is in Earth and Space. It's lesson number 4. They provide you with practice questions for each of the lessons and answers. They also give you kind of a unit review when you're finished. So it's a good resource, and it's not available in the textbook. They had to remove some stuff to make room for math. So please give it a try. Go on CAP test and choose your book, log in, register by using the word people, make up your account, and take a look at lesson number 4, the solar system. Okay. All right, I'm coming back. Thanks for hanging in with me. I've recorded this session, mistakes and all, and hopefully I'll be able to post it on YouTube so you will be able to access it. And don't be too critical of the old professor. Just trying to get the information out there for you. All right, see you on the internet.